Today we're going to be learning about combining bases. This is going to be entry 49 in your notebooks. Make sure you are setting up the input correctly on the left side and output on the right side. So we'll start off with another warm-up. I'd like you to fill in the blanks in this table to try to discover patterns in exponents when you're combining the same exponents that have different base factors. As usual, an example has been provided for you. So the first row in the column, 5 cubed times 2 cubed, that can be expanded into 5 times 5 times 5 times 2 times 2 times 2. And then if you look here, we've grouped 5 times 2 together, grouped 5 times 2 together, grouped 5 times 2 together, and made it into 10 times 10 times 10. That gives us one base number 10 with an exponent 3. Skip down a couple of lines and you'll see an example with division as well. 10 to the 4th divided by 5 to the 4th. You'll see that the expanded form spreads out the 10s on the top of the fraction, spreads out the 5s on the bottom of the fraction. You group them into 10 over 5 times 10 over 5 times 10 over 5 times 10 over 5, and then that simplifies to 2 times 2 times 2 times 2. Use these examples to help you fill out the blanks in the table that I am circling for you here. Fill these out, and you have 5 minutes to work on this. Go ahead and check your answers. What patterns do you notice when you multiply the same exponents with different base factors and when you divide the same exponents by different base factors? When you multiply two different base factors, for example, a base factor of A with a base factor of B, but that have the same exponent on them, for example, n and n, same exponent, what happens is that you can choose to multiply the base factors together first, and then just write that same exponent outside of that grouping. Let's look at an example of this. So we have negative 15 as one base factor raised to the third power, and then we have negative 5 as a different base factor also raised to the third power. What we can do is we can put the numbers into a grouping together, put those base factors into a grouping together first. So we have negative 15 times negative 5 together in parentheses. And then just take that common exponent of 3 and write that outside of the grouping. If we simplify this, whatever is happening inside the parentheses, the negative 15 times the negative 5, the negatives cancel out. And 15 times 5 is 75. And so we would have that as our new base factor, but the same exponent on the corner of it of 3. The opposite of this rule is also true. That makes it convenient to separate numbers and variables if you have a mix of them, like in this example here, where we have 3 and x, both to the second power, and we want to split that up so we can simplify a little bit more. We can split this into 3 having an exponent of 2 and x having an exponent of 2 because that's the opposite of this rule. So instead of having them in parentheses in a grouping together, we've split them up into 2 separate exponents. This allows us to simplify 3 squared into another whole number, a simpler whole number. 3 times 3 is 9, and leave x squared next to it, where it's easier to tell how much this number is worth. Our next rule deals with when you divide numbers that have the same exponent, for example, having an exponent of n on both numbers, but having different base factors, like having a as a base factor on top of the fraction and b as a base factor on the bottom of the fraction. When this happens, you can put a and b into the same grouping like you would with multiplication, and a would be on top still, b would be in the denominator still, and then the outside exponent would be the same one that they had in common. This is convenient when you're trying to divide really large numbers. For example, negative 35 to the 5th power being divided by 7 to the 5th. Individually, 35 to the 5th, if you try to multiply that out, that would be a huge number. And then 7 to the 5th, it would not be easy either. But one way you can simplify this for yourself, make this easier to handle, is you can use that division rule and write both 35 and a 7 into its own grouping. So have that grouping in that parentheses with the division happening first, and write the exponent of 5 outside of that grouping, so we deal with that later. Then we can divide 35 by 7, which gives us 5 inside of that parentheses, which is instantly an easier number to look at and work with. We still have the exponents of 5 outside of that, and you could write this as just negative 5 to the 5th power for its simplest form. Just like with multiplication, the division rule can also happen the opposite way. So in this example, we have in parentheses c divided by d to the negative 3rd power. We can simplify this by rewriting that negative 3 directly onto c and directly onto d, and then use our knowledge of negative exponents to flip the exponents so they're no longer negative. So we'll have, instead of d to the negative 3 in the denominator, it flips onto the top to be d to the positive 3, and then c to the negative 3 flips to the bottom and becomes c to the positive 3 in the denominator, and then we can then rewrite it into the division rule. So we now can put d and c into the same grouping and have the exponent of 3 outside for a better looking positive answer. I want to apply everything we've just learned to a more complex example. So this will involve remembering all of our previous rules on exponents as well as today's. The first thing we want to do when we see such a large, complicated expression is to expand it as much as possible first. So, number 1, let's expand everything. And then after that, regroup them in a way that makes more sense. I'm going to write this out into 2 to the 3rd power times 5 to the 2nd power. That hasn't changed, but I notice that I have 2 in the same grouping, and I can take them out with the opposite of the multiplication rule. So I'm going to now write the 2 directly onto the 2, 2 squared, and the 2 directly onto the 3, 3 squared. And I'm going to do the same thing with this grouping here to try to get rid of that. 3 squared times 5 squared, and this is all still over 3 squared. Next, to help me group everything in a more organized way and apply the rules of exponents, I want to look for numbers with the same base factors. So I noticed that there's 2 to the 3rd here and 2 squared here, and they both have the same base factor of 2. I noticed that 5 squared and 5 squared both have the same base number 5, and I noticed that 3 squared, and 3 squared at the denominator here all have the same base factor of 3. So I'm going to combine my exponents that have the same base factors together. Notice that when I multiply the same base factor, I can add the exponents. When I have the same base factor of 5, I can add those exponents of 2. When I have the same base factors of 3, I can add those exponents of 2 on the same part of the fraction, all in the numerator. The denominator does something different, so I'll leave that until the end. This will simplify to 2 to the 5th power times 5 to the 4th power times 3 to the 4th power over 3 to the 2nd power. Now I can apply my division rules here. Remember, if I have the same base factor 3, then I subtract these exponents. So I'm going to rewrite this into 2 to the 5th power times 5 to the 4th power times 3 to the 4 minus 2. And then I can rewrite this as 2 to the 5th times 5 to the 4th times 3 to the 2nd. And that would be it That would be the simplest form I can get this into because there are no other factors that are the same. These are all different factors, and there are no exponents that are the same. Our last question here asks if 2 to the 5th power and 3 to the 4th power can be simplified to have one single exponent on a number. To answer this question, we need to know about the two multiplication rules that we've learned about when we're dealing with exponents. The first multiplication rule we talked about is when you have the same base factor, you can add the top two exponents together. But in the question, with 2 to the 5th power times 3 to the 4th power, 2 and 3 are not the same base factor, which means you can't just add the exponents 5 and 4 together. The exponent rule we just learned today about multiplication is if you have two different base factors but the same exponent on those base factors, then you can write the base factors into a grouping together. However, this also doesn't apply to our current example because the exponents on 2 and the exponents on 3 are different. We have an exponent of 5 and 4, which are not the same. This means we can't just stick 2 and 3 into the same grouping and multiply them first before doing something with 5 and 4. We can't simplify this exponent that way either. So our answer is no. 2 to the 5th power times 3 to the 4th power is already simplified.